Hello everybody, my name is Ghazal. I'm a master graduate at TU Berlin campus Laguna and currently working as a project engineer at Zika company for stormwater management. In this video, I'd like to share with you the main outlines of my master thesis, which has been awarded the Nachwuchspreis for the master category. So the main title of the thesis was Urban Flood Protection in Arid Regions for Study Area King Fahd Suburb in Dammam in Saudi Arabia. The main concept of this video is the motivation of the study, concept adopted, study area, method and tools, the main results, and at the end, the conclusion. Starting with the motivation, if we have a look here on these photos from recent flooding events happened in arid cities in both Egypt and Saudi Arabia, we can see here that not only the humid areas can suffer from flood risks, but also the arid regions. Why? Usually because of climate change and the unreadiness of these cities to face such kind of flooding problems. Usually there is no flood or stormwater mitigation, flooding mitigation or stormwater drainage systems, and even if they exist, they have blocked inlets or big sedimentation inside the pipes due to the long dry seasons and strong sandy storms. Now, what is the main concept adopted in the study? Usually we say the main approach used for flood mitigation in the arid regions is using the stormwater network, either the combined one or the separate ones. However, these kind of systems have some problems called end-of-pipe problems, which means we accumulate bigger volumes of runoff, high flow peaks, and more amount of contaminants at one location at the end of the pipe of the system. Then we have to solve a big problem, which is expensive. However, if we apply the sustainable urban drainage systems, or what's so-called SUDs, which are decentralized systems or measures which aim to mitigate or deal with the stormwater runoff on site as much as possible through going several steps like prevention, source control, site control, regional control before going to the disposal point or the receiving water calls, we will have smaller problems to deal with, which is also cheaper. Some examples of SUDs are green swales, stormwater systems, tree pits, permeable pavement, permeable asphalt, and there are other many examples. The study area of this thesis was King Fahd suburb in Dammam in Saudi Arabia. It is about 35 kilometers square, typical residential neighborhood with some commercial and industrial land uses. The local authorities of Dammam city was looking for stormwater drainage solutions because they are suffering from pluvial flooding and also fluvial flooding from the neighboring catchment, as we can see here the streamlines on this map. The datasets were available about this study area where the digital elevation model 10 by 10 meter represented topography, 90 boreholes giving an idea about the hydrogeological status of the area, land use map, and some IDF curves from the literature about the MEM city, which were used to create or prepare the design storm for the modeling. Method and tools. Since we are talking about urban flooding with multi-directional waterways, the main method used for study was performing 2D hydrodynamic or hydraulic modeling using InfoOr's ICM software. Also, some other softwares were used like StormXXL for preparation of design storm and ArcGIS for data pre-processing. The two main tracks of the modeling process were base scenario to determine the basic flood condition of the area without applying any kind of mitigation measures. The second one was the mitigation scenario after implementing SUDs as flood mitigation measures to see the impact and compare the results. The simulations were done based on the fluvial flooding only. Fluvial flooding only was considered without considering the fluvial flooding for return periods 10, 25, and 100 years, stormwater duration of 3 hours, and maximum simulation time of 12 hours. For the mitigation scenario, two strategies were proposed. The first one was to apply stormwater systems for all buildings to collect runoff from rooftops, and in addition to applying rock lines swelled in the medians of the main big roads, to allow infiltrations. At locations where the groundwater table was high, concrete line swales were done without infiltration to just store some water on the surface and allow evaporation. For strategy 2, permeable pavement were proposed for all walkways and medians and sidewalks within the city, without the streets, no streets, to allow infiltration. For areas here in red, where groundwater table is high, nothing were proposed, no infiltration. The systems were applied in the model by excluding the buildings area. The swells were applied by making or creating depressions on the mesh of the model. And the permeable pavement were applied by changing the infiltration parameters using the green amped method in these blue areas. Unfortunately, due to the limited time of the video, I cannot show all the results, but I'd like to share with you the animation from the main results of the most extreme event from the model. Here we can see the base scenario, strategy 1 and strategy 2. I'd like to play it. And as we can see here, the most extreme flooding conditions happened with the base scenario without any measures. After applying strategy 1, it was relatively or partially mitigated. But if we apply strategy 2, the mitigation levels achieved were even higher, and the performance of the mitigation scenario were even better. As a graphical representation of these results, we can see here the total percentage and the reduction of the runoff volume. If we compare for the 10 years, 2500 years, and if we compare base scenario strategy 1 for the 3-year term periods, we can see that reduction volumes ranges from 20 to 30%. And if we compare the base scenario with strategy 2, the reduction in the runoff volumes ranges from 50 to 40%. Another assessment of the results was done to answer the questions how much we can optimize the need of stormwater networks for this area. If we can see here in this graph, the blue line represents the runoff volumes of the 10-year event of the base scenario, which also can be roughly considered the capacity of the 10-year network required for the area. And if we compare the runoff volumes from strategy 1, we can see that the 10-year runoff volume were reduced to a level which is less than the capacity of the network. The 25-year runoff volumes were reduced to a level which is very close from the 10-year capacity of the network, which means that for the 10-year, after applying strategy 1, we can optimize the network sizes or even get rid of it completely. For the 25-year, it means that if we combine 10-year network with a 10-year network with a strategy 1, we can achieve very good mitigation levels against the 25-year event. However, for the 100-year event, still the runoff volumes are much higher than the network capacity, and we cannot achieve good mitigation levels even if we combined both systems together. Same comparison or assessment was done for the strategy 2, and as we can see here, the 10-year and 25 years runoff volumes were reduced to level less than the capacity of the network, which means we can reduce the network, or even there will be no need for a network in this case. For the 100-year event, and this is very interesting, that the 100-year runoff volumes were reduced and even intersect with the capacity of the network. That means that we can achieve very good or acceptable mitigation levels if we apply a 10-year network with strategy 2, which is a permeable pavement, even against the most extreme event, which is a 10-year event, 100-year event. So what is the main message from this study was to answer the question why it's time to consider SUDs in arid regions, simply because they are simple techniques, easy to construct, easy to integrate in the landscape of the cities. They can reduce problems of end-of-pipe solutions by locally deal with the runoff waters. They can possibly nowadays can be simulated due to the existence of strong software packages and strong computer processors. The model results show that they can significantly reduce the runoff volumes within the cities, urban areas, and also can lead to some optimizations in the need of stormwater networks. Here are some of the references used in the study. Thank you for watching the video. I hope you find my study interesting and I wish you a nice day.